right? And quickly lengths. As you can see, this looks like what, you people? Right, there we go. So we're going to be doing some trigonometry today. So for the next 2 weeks, we're going to be covering trigonometry. Obviously, next week we'll be back into tuition like usual. So don't stress about it. This week we're just going to do something relatively short. Should take us about 20 minutes to finish a question like this. Not something difficult. Now remember, each question in your geometry will be based out something like this here. You have this here to start off with. So if we're looking at this specific question, let's just look at what details they're giving us before we rush and go ahead to try something else. So if you look at, they gave us the hypotenuse to be 17, then they told us that this is alpha, they told us that's k, that's 8. So if we now go ahead and we go, before we actually answer this specific type of question, right? So before we do what? Before we answer a specific type of a question, right? Let's basically or mainly look at how we're going to answer this specific question. If that there is going to be your x and that's going to be your y. So if you take it out, you know that that's 8 units there, and we know that that's k. So how do you do? Now you've labeled all your sides, right? You know now according to A that will be opposite, adjacent, and your hypotenuse. So we know that no matter what, 17 will always remain our what? Our hypotenuse. It will not change, right, youngsters? Perfect. Now it says, the first thing or the first step that we will do with regards to the set, it says determine the value of k. So we go ahead and we can solve for k. Lovely. Then it says write down the value of cos of alpha. So you go ahead and you solve for cos of alpha. Then it says a plus b is equal to 180, determine cos of beta. A little bit of something tricky there. Not so bad. Then it says determine sine of beta minus alpha. Lovely. Then we know that this is a proof. So it's prove your left hand side. So prove your left hand side is equals to your right hand side. And then as we can see, this here is a bit of a general solution. Lovely. And this would count for, all of this would count for about 20 marks in your final paper. So next week, few weeks, we're going to be strengthening up trigonometry. But don't worry, next week tuition opens up full swing. Lovely. So let's talk about this specific things that you're going to take into consideration with regards to this here. Alright. 8.1.1. Do you agree with me that it says determine the value of k? Now you have a right angle triangle. So if you have a right angle triangle, the best way forward to determine the value of k is to do what, youngsters? Is to do theorem of Pythagoras. Right, youngsters? Lovely. So let's go ahead and see. Right? The first thing that we're going to do with this is we're going to say it will be your h squared is equals to side 1 squared plus side 2 squared. Now we know that we have h, so side 1 squared will equals to what, youngsters? It will equals to 17 squared minus your 8 squared, which now will give us the value of k squared. Now we root it and we root it, so 17 squared plus 8 will now give us the value of k. Can you people all see that? How simple that is, how easy that is to understand. Right, so all we can go ahead and basically do is remember it's a square there. So we're going to go ahead and we're going to say in our calculator, so let me show you how I'm typing this out. Going to go 17 squared less 8 squared in your calculator, press equals to, and it gives you 15. So now it's showing the value of k is equals to 15, so k is equals to 15. Right, now you make you go ahead and write it in case you need to erase any of this. So you get 8.1.2. Now, write down the value of cos of alpha. So, with regards to cos of alpha, how do you think that is going to work out for us? So, we're looking at alpha with regards to cos of an angle. It's equals to your what? Your adjacent over your hypotenuse. And with regards to this here, my adjacent side is 15 and my hypotenuse is now 17, and that's your answer for 8.1.2. Then it says determine alpha plus beta is equals to 180, determine cos of beta. So we're going to look at 8.1.3, right? With regards to this here, this specific way of doing something like this, a cos of beta, before is you need to calculate alpha. So if you go, a cos of alpha is equals to 15 over 17. Solve for alpha. So you take the cos over, it becomes cos to the minus 1 is equals to 15 over 17, and then you get alpha. Can you all see that? Quite simple, quite easy to understand, right? Then we're going to see what we can do with that specific thing. So you're going to say cos of 15 all over 17, shift cos, right? So if I show you people how to do it here, you're going to go ahead, you're going to say shift cos, so it gives you cos to minus 1, 15 over 17. Then we're going to close it, and then it gives you about 28. So let's just leave it at 28 degrees if you're looking at that there. Lovely. So say we need this here to be what? 28 degrees, right? Now you go ahead and you do what, youngsters? You now say alpha plus beta is equals to 180. So beta equals to 180 minus alpha. And 180, what did we work out alpha to be? 28. So 180 minus 28. 180 minus 28 is equals to 152. 152. Then it says determine the value of this here. So before we carry on, we know that this here is what? 100 and we know that beta is what? 128. We know that alpha that we've solved for is 28. Right? Let's get the messy angle here. So we have 28 plus 90, which gives us 118. So 180 minus 118 will give us 62 over there. Right. Now we're going to have cos of 152. So cos of 152. Can't you reduce cos of 152 to be what? Youngsters? Quite a simple thing. Come, if everybody thinks for me, 180 minus 152. Or minus 28, sorry, 28 will give us negative cos of 28, which gives us negative 15 over 17. And that's your final answer. So let's just recap as to what we've done there. The first thing we've done is we had cos of A, if we from the previous question, we solved for cos of A to be 15 over 17. We then done what, youngsters? We went ahead and we solved for this alpha is equals to cos to minus 1 over 15 over 17, and that gave us 28. Remember, I rounded it off, linear is the whole number. We then took the 28, we now sub it in here to get beta. Right? Then it's basically like solving for the missing one, we got 152. Then we put 152 cos of 152. But then I went and I worked out all my missing angles here. Now, did I have a cos of 152? No, I did not. So what do I have to do there? I had to reduce it. So how did I reduce this? I went ahead and I said cos of 152, which is 180 minus 28, reduced. Now, how does it become negative? 180 minus is inside its quadrant. Is it cos negative inside its quadrant? Therefore, we went ahead negative cos of 28. Then we knew cos of 28 is your adjacent over your hypotenuse, which is 15 over 17, and then obviously the minus will remain there. So please guys, have a look at this specific question a few times just to ensure that you know what you're doing, or you know that you're getting the correct answer with regards to this here. And we're going to go on 8.1.4. So 8.1.4. Right? It says sine of beta minus alpha. So sine of my beta minus my alpha. Alright. So there's two ways that you can go ahead and do this, right? You can go ahead and expand it, or you can fill in your degrees. I would say the easier or the suggested way is to go ahead and fill in your degrees, possibly, right? So, if you're going to have a look at something like this here, right? So, what would I have done? What I wrote this question is, I would have signed 1 over 52, which is 152 tried minus 28, which now gives you, if you say 152 minus 28, it gives you 124, right? 124. Okay, so that's what I would have done. And then I would have reduced this 124 to now go ahead and write out as 180 minus 56, which gives you that. Then what I would have done is write sign of 56. Now if you look here, you do not have a sign of 56, but what is this here? This is 28 double. If you say 28 multiplied by 2, it gives you 56. So if you go 28, right, so if you're going to go 28 multiplied by 2, as you can see, that's 56 over there. So what does this mean? You can change this to a formula using a double angle rules. And what are your double angle rules, youngsters? You can say 2 sine of half of it, 28 cos of half of it, 28. Now try to go ahead and fill it out. So it's going to be 2 sine of 28 is going to be 8 over 17, right? And cos of 28 is 15 over 17, and then you close it. And then you now can go ahead and do what? Calculate your final answer with regards to this specific thing here. So you're going to go 2. So we're going to go like that. There 2 into that, right? 8 over 17. Close the brackets, multiplied by 15 over 17. And then we're going to close it, which gives us 240 over 89. Right. Which gives you what? 240 over 289. Let me just press yes. 240 over 289. So let's just redo that there, or recap of the time. What I would have said is 152 minus 28, which gives me sine of 124. After that, I would have reduced the 124, got the sine of 56. And then I would have tested if that 56 is a double angle, if it's one of that angles minus the other angles. Got my answers, and then expanded it using my double angle formula because I knew it was a double angle, and then just got my final little answer. Lovely, youngsters. Perfect. Now we're going to move on to 8.2. So as you can see, we've done the whole first question. This question would have been about 4 marks, maybe 3, 2, and 2. Alright? Not such a difficult question, but some thinking to be done, obviously. Alright. Now if you're looking at this here, it says prove your left hand side is equals to your right hand side. So we have 1 minus cos of 2x minus sine of x all over sine of 2x minus cos of x is equals to 10x. Done. So now that we have this specific thing over here, let's go ahead and see how we can change this here. So remember, you must always try and change this cos of 2x to cancel out with that 1. Right? So we have 1 minus. How am I going to let it cancel out with it? Is it if I say 1 minus 2 sine x? Right? So 1, then it will become plus 2 sine x minus sine x all over 2 sine x can change into 2 sine x cos x minus cos x. Then this 1 and 1 will cancel. You now can take out what is a common factor here. You can take out sine x as a common. You're left with 1 minus 2 sine x squared. You're left with sine x minus 1 Right? Then here at the bottom you can take out obviously cos 2 sine x minus 1. You can take out cos x at the bottom, 2 sine x minus 1. As you can see that, and then cancel sine over cos or equals to tan of x. Quite a simple general solution, but this prove your identities using left hand side is equals to right hand side. Quite a simple one, not something a very difficult, but youngsters, remember just to change that so you can always cancel out with the one in front. The minute you see that one you're using to do what, youngsters, to cancel out with the one in front, the minute you get that there, you know you're 150% correct. Lovely. Quite simple, quite easy, not anything difficult, not anything to scratch your head about. Right, now we're on to the last question over here. And our last question over here is 8.3. Right, so if we're looking at 8.3, we have a general solution. So it says a sine of 2x minus cos x is equals to 0. So as you can see, something like this is not simplified. The first thing that you need to go do is simplify. Get these angles to be around the same thing. So it becomes 2 sine of x cos of x minus cos x is equals to 0. Then we can take out what is a common cos of x. Then we need to be left with 2 sine x minus 1 is equals to 0. Now we have them both in brackets. So we can say cos of x is equals to 0 and then solve for this. Why? This is a special rule, so please go and look up your special rules in your books and you will find the solution for this here, right? And then this here we can go ahead, it will be sine x is equals to 1 divided by 2. So sine x is equals to a half. Lovely. Now you need to go ahead and do what? Find out your reference angle. So you need to go ahead and find out your reference angle. Your reference angle is sine to the negative 1 of a half, like that there. This here, if you go ahead and plug it in your calculator, you should get 30 degrees. So remember, you're going to say reference angle, so it's shift sine, see as you can see sine to the minus 1. 1 all over 2, close the brackets there. Lovely, quite simple, quite easy. 30 degrees, can you all see that? Perfect, not so bad, not so difficult. Lovely. So now you've got it to be 30 degrees, right? Now remember, sine, it's positive here. So where is sine positive? It's positive in the first quadrant and in the second quadrant, right? So with regards to this here, you need to draw both the quadrants, right? So in your first quadrant, isn't this 0? So it will be what? X is equals to 0 plus 30 plus 360k. Now remember, it's just going to be 30 plus 360k. Then it's positive where else in the 180 minus the green. So you're going to go, isn't x is equals to 180 minus 30, can you see your reference angle? Reference angle plus 360k. So if you go ahead and solve for this, it gives you 150 plus 360k x. And then you are complete. You can throw in x there, and you are complete there as well. Alright. So something like this, maybe 5 marks in your paper. So a total of, let's see, 5 marks over here, say 5 marks for this one as well. So that's 10, and say 10 here from all of them here, 10, right? 4, 8, and 1 and 1, or maybe 4, 3, that's 7, 2 and 1, right? So about 10 marks there. So as you can see, total here 20 marks in your final paper, which is quite a lot of percentage in your final paper. These guys, make sure you guys do this here. All the best of luck. And next week tuition will be open, so I will see each and every one of you. Stay safe. Keep well. Stay safe.